Hi, this is Simon Obstill and welcome to this sixth and final part of this compositing school series for Apple Motion, in which we've been looking at the science and craft of green screen keying. So in this part we'll be looking at the underlying theory, and I hope that's going to tie up all those loose ends for you. So let's get started. So here we are. This is the green screen plate that we started with, this shot from Hollywood Camera Work, and there are plenty of issues with trying to key it. It's got a very nice flat solid green screen background, but there is an awful lot of green spill in the foreground, which caused us quite a bit of difficulty. And of course there are these tracking marks on the background that need to be taken care of, and there's this nice hair detail that obviously we wanted to preserve as much as possible in our key. So the first step to creating our key was to pull a raw matte, as it's known. And the raw matte looked like this, and what we did was we used the subtract blend mode to subtract the red channel from the green channel, and that is how we came by this image here. So obviously in the backing, if we look, there is very little red, and conversely in the foreground the red tends to be brighter than the green. There are, of course, some areas where the green is indeed brighter than the red, but unlike in the backing, they are not very much brighter. So that is why when we subtracted the red from the green, we got this dark area for the foreground and this brighter area for the background, because obviously in the background we're subtracting less red than we are in the foreground where the red is dominant. So that's how we ended up with this raw matte. Again, as I say, we used the subtract blend mode to do that, having split the green and the red into their separate channels. And we did that with the channel mixer. So the next thing we had to do was to get the backing area to be completely white and the foreground area to be completely black. And we did that using a basic levels on the result of our raw matte. And we ended up with this. We were obviously still left with the tracking marks. That was something we came back to much later on with a refinement of the basic raw matte. But anyway, so then we were left with this, the scaled matte effectively. So the raw matte scaled using levels. So the next thing we need to do is invert it. So the way that a matte works is the areas that are white remain solid, whereas the areas that are black become transparent. So to do that, we took our scaled matte and we applied a negative filter just to flip it around to get this. So then we had to think about creating our key from this matte. And to do that, we used the magic maths of 1 and 0. So if you multiply any value by 0, you get 0. And if you multiply any value by 1, you get the same value back. And this is the maths that really drives the whole matting process and the keying process by extension. So if we look at our matte, white has a value of 1 and black has a value of 0. So anything we multiply by the black is going to be black, and anything we multiply by the white is going to stay its original color. So that's what we did. Now we did this. So we multiplied our foreground by the matte. So foreground times matte, and we used the multiply blend mode to get that. So you can see that all the backing areas are now black, and we can see our foreground character against that black background. And then we needed to treat the background in the opposite way. So what we did was we took our background, this city shot, and we multiplied it by the inverted matte, and the result of that is we got a black hole where our foreground character lives, but we obviously could see our background in the backing area, because in the inverted matte, if we look at this is the inverted matte here. In fact, it's our original scaled matte without the negatives on it. You can see that the backing area is all white, and that's why we see our background, and the foreground is all black. That's why the foreground has been suppressed to black. So that's how we got this matted background image. So then what we could do is we could simply add those two together. So this is what we got. We added together our matted foreground and our matted background using the add blend mode. And if we look at the maths of that, it's pretty obvious, isn't it? The result of adding is if you add a value to 0, in other words, to black, you get the value. And if you add 0 to a value, you also get the value. It's kind of as obvious as maths get. That's why we can see the background here, because in the foreground, this area is black. So we're adding 0 over the background here. And here, the background is black and the foreground is got positive values. And we're adding these foreground values over that 0 value in the matted background. And that's how it all works. So very, very simple when you actually break it down like that. So the problem we had at this stage, of course, is that we've got all of this excess green that we can't live with. So we needed to find a routine to remove that. And that routine is known as despill or spill suppression. So to create our spill suppression routine, the first thing we did was to create what's known as a spill map. And to do that, we actually used essentially the same technique as when we created our raw mat. In the case of the raw mat, all we ever did was subtract the red from the green using the subtract blend mode. In the case of this spill map, we decided to leverage a little bit of the blue as well in that subtraction process. And we used the darken blend mode to get the minimum of the red and the blue. In fact, that's a slight oversimplification because we only used 50% of the blue within that operation. But essentially, that's what we were doing. Now, this green minus the minimum of the red and the blue, or indeed more usually the maximum of the red and the blue, this is the form of the raw mat extraction process that you'll most commonly find. We used this very, very simple version, but in actual fact, we also came back and revisited it later on and did indeed leverage the blue in pretty much the same way as we did with this spill map. I just wanted to show you a very, very simple raw mat initially, but this is how it actually works if you read the handbooks. Anyway, enough of that. The point being here is that we've created this map of wherever the green is greater than the other channels. And this is going to be useful because we can use this to subtract from the green channel itself. So that's what we did in the next step. We took our main green screen plate, which has got all of that green in, crazy amounts of green, and we subtracted the spill map from it. So that's the spill map, and we subtracted it from the green screen plate, and we ended up with this. So the result of that is we've taken away the excess green. So that at no point is the green brighter than any of the other two channels. And you can see it's taken care of the green on her coat and all of that green on the edges of her hair. So that's a much better new plate to be using than this one here, which gave us this horrible composite like that. So what we then did is use this despill plate instead of the original plate. So we got this. So this is our despilled key. So we took our despilled foreground and multiplied it by the mat. And again, we took our background and multiplied it by the inverted mat. So we just literally swapped out the plate for the despilled foreground. And there again, we were using the multiply blend mode and the add blend mode. So that's how we came to this key here. But as I said just earlier on, we ended up coming back and trying to sort out these tracking marks by revisiting our raw mat. And what we did, as I say, we leveraged some of the blue channel as well. And in doing so, we were able to get rid of those tracking marks. So just to summarize the maths of that core mat extraction process, typically what you'll see is that it's created by subtracting the maximum of the red and the blue from the green, or as in our case, subtracting the minimum of the red and the blue from the green. In most professional keyers, you'll get control over which of these processes is being used, and you'll be able to blend between them and so on. You'll have quite a lot of control, although the actual processes tend to be disguised by extremely unhelpful naming conventions. But essentially it's about finding the best possible combination of the red and the blue channels to subtract from the green channel. And this incredibly simple process basically drives the entire green screen keying process, as we have seen. If you've followed this entire series, you'll know that we went into a lot of extra detail on refining the key in lots of different ways. But you will also have discovered that everything ultimately came down to that extraction of that original mat. So I hope that's started to make a bit more sense to you. Thanks very much indeed for watching. I hope you've enjoyed this series. I'll see you again soon.